Decision structures. So in this nugget, we're going to look at how we can give our application the ability to make decisions. So we're programming intelligence into our applications, and in a nutshell, really what we're doing is we're just controlling the flow of how our program executes code. So it's called the flow of control. And really that's just going to determine what code executes based on conditions. So that's all it is in a nutshell, and I'm going to give you some good real-world examples here when we get into our slides. But no, for now we're just going to look at all the different ways using the if statement and the switch statement, how we can control the execution of our code within our application. So let's jump right into the outline here. We're going to start with an introduction to algorithms and problem solving. It's good to get this stuff down on paper, especially if you have complex decision making that you need to program into your application. It's great to get it on paper. So I'm going to give you some good tools that will allow you to do that using things like flowcharts and decision tables. So we'll take a good look at that, and again, we'll look at some real-world analogies when it comes to decision making within our application. And then we'll jump right into the code here and take a look first at an introduction to decision structures. We'll just talk about how to work with some basic if constructs, if statements as we call them, and also some basic switch statements. And we'll do some cool stuff in here. And then we'll take it to another level here, and I'll show you how you can do things like nested if statements and some complex switch statements. So let's start things off here with an introduction to algorithms, problem solving, and I just want to give you a brief real-world analogy of decision making in the real world versus in applications. So I gave you the brief rundown here of what the technical description of decision structures are here within the application. The technical description again here is based on a condition we're going to execute a block of code. Well, let's take this into the real world for a minute, because us as humans, we make decisions every single day, right? Whether we're driving or whether we're walking down a hallway, we need to make decisions on what we're going to do. If we're driving, we come to a stoplight, we need to make a decision on the fly there based on the color of the stoplight. If it's green, we're going to keep going. If it's yellow, depending on who you are, you may speed up or slow down. And if it's red, you're going to stop. So our condition there is the color of the light. Our action to be performed then is going to be, go, slow, or stop. So it's no different inside of an application. It's the same thing. We need to set up that condition, analyze that condition, and based on the result of that condition, execute a certain block of code. And that's going to be easy to do when we have a little, a small number of conditions, like the stoplight example. We only have 3 possible outcomes there, so we're going to have 3 blocks of code that we could execute. If we had a lot of conditions, that's where things are going to get a little more complicated, and that's where we're going to use what's called the switch statement. So we're going to use the if statement for simple things. We're going to use a switch statement for complex things with large ranges of variables. Now, moving on to algorithms. Algorithms are a great way to document the solution to a problem. So that's all algorithms really are, just a method for solving problems, and there's lots of different ways to express an algorithm. Some of the common ones here that we're going to look at are flowcharts and decision tables, but it's really going to depend on the type of problem you're solving. If you're solving, a complex math problem, then obviously you're going to use formulas to document the algorithm. But when you're doing things like documenting flow of control within an application, maybe you're documenting a data flow, maybe you're documenting a system flow, within your network. There's lots of different flavors of flowcharts. We're going to look at how we can use flowcharts for program control, and also decision tables for program flow of control here when you have, again, a lot of variables in play. Now let's start with flowcharts, and I've got a very simple flowchart I put together here that documents a process of getting on an amusement park ride, like a roller coaster, for instance, because you'll have to be a certain age or a certain height. So I've documented the process of getting on and being the attendant, the person in charge of this process. And the reason I chose this is because we kind of get all of the basic symbols here, the circle, the parallelogram, the diamond, the rectangle, and then our flow of control lines. Those are all the basic ones. You can create some, a flowchart that can cover pretty much anything with these basic symbols. Now, I've seen some super complex flowcharts up there that would take up an entire wall, so you can get really detailed with these because you can create branches off branches off branches and just keep going. So they're great for doing that. In fact, I've seen some cool ones as far as troubleshooting a PC goes that has branches for troubleshooting your video card, your hard drive, your processor. I mean, absolutely everything, memory, and it's really cool and really detailed. So Google that one if you want to see it. It's certainly out there on the web. But just to get you familiar with some of the basics here, ovals or circles are your start and end points. So these are just start and end of the process, and that's all there is for circles. Parallelograms are input-output operations. The first one we have here is an input operation. We're getting data as the attendant from the individual asking them their age. Hey, what's your age? So we'll get the data at this point, and then based on that data, we're going to make a decision. So triangles are decision points where we can start branching off. So we're going to say, hey, are they old enough? No, if they're not, we're going to head over and tell them we're sorry, you can't ride the ride. So this will be an output operation because we're sending back out to them a message saying sorry, in which case this will branch down and it will end the process. If they say yes, however, we're going to go to a rectangle, and a rectangle is just a simple process. There's no input-output operations. It's just kind of a do-it thing. So get on the roller coaster, and then they'll enjoy the ride and also come to the conclusion here of an end. So circles, rectangles, start and end, parallelograms, input-output operations, diamonds, decision-making, rectangles, processes, and then our lines are our flow of control, where they go. So flowcharts can get complex when you have a lot of conditions, and they can actually get pretty difficult to create and difficult to read when you do have large flowcharts. So decision tables are great for when you have many conditions because it's a much more compact format, and I'll show you running some tests here. They're actually pretty easy to read. So this specific decision table gives a discount based on an age. So say we run a restaurant and we want to give a discount if they're under 20 or over 60. And then that's what we have the decision table for, not only to find out what their age is and give them a discount based on their age, but also to ignore anybody, give them a 0% discount, anybody that's greater than 20 and less than 60. So we're ignoring that range, and I actually cleaned up our decision table to take the 0 out because it doesn't make sense to have that in here at this point. All right, so here's how the format of the decision table works. The percent off down here, this is considered our action. And you can have multiple actions, and if you do, I'll show you a different way to write this table. But this is a very simple decision table of one action, so we can get away with a very clean looking format here. So let's consider our action. These are considered our action results here, our discount, our percent off. Up here we have our conditions going down here. These are our conditions, and then the grid are just the values of the conditions, and we'll match them up with the discount. So the best way to do this is to run a test through it, run a variable through it. So let's create a variable here. Let's call it age. Let's create it equal to, say, 7. All right, so we have a variable that's age 7. Let's run it through. Each rule, and these are also called rules, conditions, pretty much the same thing. So first one, age less than 5. Is 7 less than 5? That would be a no. How about age less than 10? That would be a yes. How about less than 20? That would be a yes. How about greater than 60? That would be a no. So if we run this through the chart, let's match it up. NYYN. Nope. Nope. Hey, there it is. NYYN. So we would get a 15% off to anyone under 10, which is 7. So that's how that works. That's how we can match these up. And you can do the same thing here. Let's do a 61, for instance. So age equals 61. Less than 5? Nope. Less than 10? Nope. Less than 20? Nope. Greater than 60? Yes. So there it is. NNNY. 5%. So that's kind of how we match it up. Anybody less than 5 would get a 20%, less than 10, 15, less than 20, 10, greater than 60, 5. And now you can kind of get the visual on how that looks. So decision tables are just a great way to get all this data out on paper, run some tests through using variables to make sure that your conditions meet your intended actions. And then it just makes it that much easier to translate all this data into a switch statement in your code. So we'll take a look at switch statements here shortly. And now one more way to write this here is if you have many actions, what you'll do is you'll have this table split in half where the top part will be your conditions and the bottom part will be your actions. So if we had multiple actions down here, actions 1, 2, and 3 for instance, what you would end up doing is putting a check mark when it's true and an X when it's false. So it would look something like this then. And then X, check mark, X, check mark. So that kind of thing. And then you match up your bottom conditions with your bottom actions to find out if it's true. Another way to write these. And in our example here, we could have did something like action 1 was give away a toy, a children's toy. If they were under 5, give away a toddler or a larger child's toy if they were under 10, and then maybe give away dentures if they were over 60 or something like that. So we'd have all those actions that would line up based on their age. So we're going to get into C# here and see how we can make decisions using if statements, if then else statements, and those are just ways to make branches in your application, just like here. This is where a good if statement would be, because we would analyze the condition here. Are they old enough? And if they are, we would move on to this branch of code. If they're not, we would move over to this branch of code. We're going to use a switch statement when we have a lot of conditions in play. So we'll specify our condition, and then we'll make a bunch of case statements within the switch construct to decide which block of code to run. So the if then else statement and the switch statement is what we're going to look at. Let's jump into C# over on Nugget Lab and take a look at how we can do this in Visual Studio. So I'm going to open up Nugget Lab here. We'll remote desktop right into our virtual lab here. We'll go down to the Start button and fire up Visual Studio 2010 Express, the C# version here. And we're going to create a new project. So let's hit the New Project button. We're going to create a console application to start. We're actually going to also create a Windows Form application. So we'll get a couple of projects within what will be our solution here. So let's just name this one. How about making decisions underscore console? And we'll hit OK. That'll create us one project inside of one solution. Let's just rename the solution here so it doesn't look like the same name as our project, since we'll have multiple ones in here. And let's just make this look like the actual Nugget headline here. We'll call this Decision Structures. There we go. Now, one more thing to do here, just a little bit of cleanup. Let's just make this namespace consistent with the rest of the demos here. We'll call this Nugget.demos underscore 98 underscore 361 underscore 03. There we go. We look good for our namespace. And now it's time to get to business. So let's start with a very simple if statement. And what we're going to do is take data from a user, say have them enter a number, and based on the number, give them a message back. So we'll have a couple of different blocks of code to run based on the size of the number, and it'll illustrate just a very simple if statement. So let's create our own method here. We'll call it static void simple if. And then in here, let's just get some data from the user first, or at least tell them what kind of data we're looking for. So we'll do a console.writeLine. How about enter a number? Alright, so there we go. We're asking them for a number. Now we need to take the number that they enter and store it inside of a variable, because that's going to be our condition. Our condition is the number. So let's do an int your num equals console.readLine. And now C# is going to like this all by itself because we need to do an explicit conversion here. As you can see, it says cannot implicitly convert the string to an integer. You need to do it yourself. And in a previous nugget, I showed you the convert class, convert.toInt. Well, I'm going to show you a different one this time. You can also do an int.parse. And there are minor differences between the two. The point here is I just want to show you there's many different ways to do things in programming, so it's good to get familiar with all of them. So now that we have our number and our condition, we need to write this if statement and then a couple of different branches of code so we can do those actions based on the condition. And here's how you write an if statement. You start with if. Now this is kind of cool. In C#, you'll notice we've got this little snippet here of if. This stands for this icon here, little ripped piece of paper with some line on it, document icon, is just telling you that this is a code snippet. So if you hit tab twice, it's going to type out the skeleton for us. So it's highlighting our condition here, as they call it, the expression to evaluate. So this is the structure of an if statement. It's just if followed by our condition in parentheses followed by the actual code to run if the condition is true inside of our brackets. So let's just say our condition is going to be your num less than 100. So if it's less than 100, we're going to run this block of code here. We're going to say, let's just run a console.writeLine here and say your number is less than 100. There we go. Now if we wanted to test this, just this very simple if statement, what we need to do is call our simple if method here from our main procedure, our main entry point of our application. So that way it runs this block of code, this method here, it gets called, and then it's going to ask us for a number. So I'm just going to hit Control F5 to run the application. It's going to say enter a number, and if we enter say 70 and hit enter, it's going to say, yep, it's less than 100. So if we do another Control F5 to restart it, and this time enter how about 1000, it's going to skip that block of code, bypass it completely, and end the application. So our condition, if it's true, it runs this block of code. If it's false, it doesn't. Now let's say we have multiple conditions we want to analyze. Well, and not a lot of them, because that's what the switch statement will be for, but say we have just a few conditions we need to work with here. We can do an else if. See that? And if we do an else if and hit tab twice, it's going to do the same thing here. It's going to give us our skeleton, give us our second condition, and our second brackets here so we can input our block of code. So our second condition is, let's say, how about your num is less than 1,000. And I'm just going to copy this console.write here, and we'll just do this, less than 1,000. So if it's 100, less than 100, it's going to hit this block of code, run it, and then it's going to skip this block of code because we're all in one big if statement here. And if it's not less than 100, but it is less than 1,000, it's going to run this block of code. Now, if we were to do something like this, if I take this else out of here and do this, and it is less than 100, we'll get both of these messages. First, we'll get this message output to the window, then we'll get this message, because these are two separate if statements. If we do an else, however, like we were doing before here, now they're tied together. And the last thing we can do here is add an else, because what an else will allow us to do is catch everything else. So if we did not have, if neither of these conditions were met, if our number isn't less than 100 or less than 1,000, then it's going to run the else. So think of this as kind of our catch-all default output if none of our other conditions are true. So let's just copy this one as well here, and we'll just console write line, your number is greater than 1,000. All right, so now if we hit Control F5 to run the application, and let's just test them all out here. Here's 100. Actually, let's just do 99, right? Our number's less than 100. Good, good. That looks fine. How about less than 1,000 here? Let's do 999. Yep, it's less than 1,000. All right. Fire it up again. And how about 1,200? Your number is greater than 1,000. So all three of our tests succeeded here. Less than 100, it runs this block. Less than 1,000, it runs this block. Neither of these, it runs the else block because our number is greater than 1,000. Now let's take this one a step further and work with a nested if statement and an if statement that can have multiple conditions in it. So let's create a new method, and we'll call this one a static void complex if. Let's get some room down here. There we go. And we need to get information from the user again. This time we're going to have them enter a character into the console window, and we're going to analyze that character to see if it's uppercase, lowercase, or if it's a number, or if it's neither. Maybe it's a symbol or something. All right, so I'm just going to paste this in here, and we're going to change this message to say enter, if I can type here, enter a character. There we go. And now we need the same thing. We need to stuff whatever they're entering into the console window there into a variable so we can analyze it. So let's just do a char this time because it's going to be a character that they're entering. Let's call this your char equals console.read. And a read just reads the next character from the input stream, only it returns an integer. So we need to convert this to a char. And another way to do that here is as simple as that. The data type surrounded by parentheses before the statement that is going to do return the value. So there we go. That'll take it, convert it to a character, and store it inside of our your char variable. So let's set up our if here. Let's start with an if. I'm just going to hit tab twice here to get our condition going. And we're actually going to have multiple conditions in here. In fact, if we do a char dot is letter, and there it is, char dot is letter, and then we need to pass in our actual character here, which is going to be your char. Or, and this is how you do an or, a double pipe there, char dot is number, and pass in our char variable. There we go. So that's how you can do multiple conditions. You can separate them by ors. You can also do an and. So both of these conditions need to be true. In this case, either of them can be true. So if it's a letter or if it's a number, this block of code is going to run. Now before we get into our nested if, let's just complete the rest of this if statement, kind of our outer if statement here. And to do that, let's just add an else. And our else is just going to say, because it's not a letter and it's not a number at this point, so it's probably a symbol or something like, a percent sign, ampersand, pound sign, currency symbol, something of that sorts. So let's just type in here console dot, you know what? Let's make this easy. Let's just copy. It's always good to copy and paste code. Save yourself time. So we'll do a your char is not a letter or number. All right, there we go. Now's the fun part. Now let's create a little nested if inside here, because if it is a letter or number, we want to send back to the user if the character they entered is uppercase, lowercase, or if it's not a character and it's a digit, let them know that it's an actual number. So let's do another if in here. If we get the skeleton set up here, let's just do a char that is upper, pass in our variable here, your char. So if it's upper, then it's an uppercase character. And let's let them know that here by saying your char, your char is uppercase. There we go. Copy this. Else if char that is lower, we got to pass in our char variable here too. There we go. Then we're going to say it's lowercase. There we go. And let's add another else if onto here. Only this time we're going to say if char.isDigit, there it is digit, pass in our char variable. Then we're just going to let them know that your char is a number. So there's a better way to write this, but I wanted to write it this way to illustrate not only the nested if, multiple conditions, but also you can have more than one else if. You can have many else ifs, and you also do not need an else, as you see here, because we covered all of our conditions. Now, if we want to test this out, let's head on up here to the top. I'm just going to minimize the code for our simple if. And in our main entry point method here, let's just change this to complex if. So our complex if statement is ran. And now let's run it. I'm going to hit Control F5. Let's enter a character in here. How about our character is a lowercase t, and it's going to say your char is lowercase. We'll hit enter, and I'm just going to fire this up again here. How about we do an uppercase y? All right, okay, it's uppercase. Let's do the same thing here. How about our character is going to be a digit, 8. We hit 8. Look at that. It's a number. And finally here, let's just enter a % sign. And your char is not a letter or a number. So all of our conditions were met there. Everything looks good. And that's how we can do complex if statements with multiple conditions and nested if statements. So that's the if statement and how you can use it. And that's one of the major statements you'll be using in your software developing days because it's everywhere. You're constantly analyzing conditions and running code if conditions are met, or even if they aren't met. Now let's move on to the switch statement. And in order to do this, we're going to close out of our console application here for now. We'll be back to it. And let's add a WinForms application here. So I'm going to right click on the solution, choose Add New Project, and this time we're going to choose Windows Forms application. And let's just call this one Making Decisions WinForms. Alright, or WinForm. That looks good. So we'll get this in here. Now we've got a console, or excuse me, a WinForm application. Let's just right click and choose Set as Startup Project. And we're going to create a very simple switch application to start things out with anyway. And we're going to try to model our stoplight analogy. We have those 3 conditions. So let's try to model that with a switch statement. And first thing I'm going to do is I'm just going to delete this form out of here that we have. So I'm going to delete form 1, hit OK, and I'm going to bring in a form that I've pre-created here. So I'll right click, choose Add Existing Item, and we'll browse, and I called it Switch Form here. We'll hit Add, and it'll add it into our project here. So very simple little application here. I just made a picture box with an animated GIF in it. You don't see it animated now because you don't see animated GIFs in the design view. We have a group box with 3 mutually exclusive options here as radio buttons. Green means go, yellow means slow, red means stop. So we're going to alter what the animated GIF does based on the action performed here. And we also have a timer down here. A timer runs its code at a specified interval. So we have the interval set at 250, which is, this is in milliseconds, so 1,000 milliseconds is a second. So this is a quarter of a millisecond the code in here will run. And hitting yellow will activate this timer, and then hitting in the other ones will turn it off. And just to get you familiar here with some of the control names, because we'll be referencing them in code, we haven't written any code. We've got a blank shell. I really just did the interface so we can write the code. But this is PBCar. This is how we'll be referring to it in the code window, as PBCar. This is RB Go, radio button Go. This is RB Slow, and this is RB Stop. So those are the main ones that we'll be using inside of our code window. Now, if we want to get into the code window here, let's just go over and hit the View Code button. And you can see it's just pretty much an empty shell. This is what we get by default with a Windows form. And inside of here, we need to create a routine that we're going to call from all of, and anytime a user clicks on one of these options, then it's going to call this code. So we need one method. That way we can call this method from all of those different code blocks. And let's just call this method, how about a void do traffic light. All right, and we need to accept a parameter here, and that parameter is going to be of type string, and it's going to be the color of the light, because that's going to be our condition. Now we need to create a switch statement, so let's just do a switch, hit tab twice, and look at that. We'll get kind of our default structure. Again, this is our condition, and don't worry about the default for now. We're going to come back to this when I show you our complex switch statement. Let's just create a very simple switch statement. We're going to do this based on the color of the light, the color that gets passed in here. So what we're going to do now is create some cases. So case green, if the text green gets passed in as color here, then what we're going to do is run this code down here. And I'm just going to put some breaks in here because let's get the structure of this all set up here. Case yellow, we're going to run this. And case red, we're going to run this. And that's it. There's the basic structure of our switch statement. So it works like this. It's kind of just a much cleaner if statement, so to speak, or if-else statement, because once a color comes in, switch is going to analyze it, and based on the color, if it's green, it's going to run this code. If it's yellow, it's going to run this code. And if it's red, it's going to run this code. All right. And the break statement is there to break execution. If you didn't have a break statement, you could do, if it was case green or yellow, it would run both the green and the yellow and break on the yellow. All right. So we'll cover this and how this is useful here coming up in our complex statement as well. But for now, it's just going to run that code block based on that color and be done, and then enter, I should say exit the routine. So let's write the details here. With green, all we need to do is make sure that our car is enabled. So if we do a pbcar.enabled equals true, then it'll be running. And that's how animated GIFs work. If you enable a picture that has an animated GIF in it, then it's going to start the animation. If you disable it by setting the enabled property to false, it's going to stop the animation. And those are really the only things we can do. Yellow, again, we're doing something special with a timer, and a timer is going to, again, run every quarter of a second here. So we're just going to enable it, disable it every quarter of a second whenever yellow is chosen. So to the human eye, it's going to look like it's slowing down, even though we're kind of playing tricks on the user and not actually slowing it down. We're just enabling and disabling it at a very high rate of speed. So we'll cover yellow in a second. Let's go down to red here. pbcar.enabled equals false. There we go. So green, we turn the animation on. Red, we turn the animation off. Yellow, we just need to enable the timer. So timer.enabled equals true. And now we just need to make sure as well here that we disable the timer when it's not yellow. All right, so we'll do that there and there. All right, so that's it. Now the next step is to wire up all of our radio buttons here. So let's just double click on all of them individually. This will wire up the event handlers for them. And that's it. So now we have all three of our event handlers. And this is the check changed event. And the check changed event just means anytime someone clicks on one of these radio buttons, its check changed event is going to fire. Now, also because we have three of them in here, if you check one, you're turning it on. So this check change event is going to fire, but also you're turning off another one. So this check change event is going to fire. So it'll actually run both events anytime a user clicks on one of these. The one that got clicked off and the one that got clicked on. So this is where we can use an if statement to make sure that it's actually checked before calling our switch statement. So we can do something like this. If rbgo.checked, oh, we need to actually do this here. There we go. rbgo.checked equals true. That's our condition. Then run this block of code, and we're just going to call our switch statement, which is do traffic light, and we're going to pass in green because we're in the green event. Simple as that. Now, one thing I wanted to illustrate this as well is, and some people frown upon this because it kind of hurts readability a little bit. But you see what I did there? I took the brackets out. If you only have one statement after your if statement, after your condition here, one line of code, then you don't have to use the brackets. So even though I think it increases readability in that you don't have all these brackets all over the place and it's less code, people also say that it decreases readability because it's not consistent. So it's a preference thing. Do whatever you like. I use them both. It just depends on the situation in the code. All right, so I'm just going to paste this code into slow here, and we just need to change this to slow, and then we need to change the call to yellow. And again, here we need to keep things case sensitive. Everything's case sensitive here in C#, so got to make sure that it's typed the right way. And here's our stop, and we're just going to pass in red for stop. So now everything's wired up. Again, the if just ensures that we're not checking off, but we're checking on the specific control. So no more running code twice. And we do an equals true there. And then if that's the case, we're going to call our do traffic light switch statement, or I should say our method, passing in the color to the switch statement, and it'll run that block of code. So the only thing left to do here is wire up our timer. So let's do that. Let's jump into our switch form and just double click on our timer. That'll take us into the tick event. So the tick event gets fired as long as it's enabled based on the interval. So every quarter of a second, since we have our timer set up with an interval of 250 milliseconds, which is a quarter of a second, every quarter of a second, as long as this timer is enabled, it's going to run this code. And the code we're going to run here is pbcar.enabled equals not pbcar.enabled. So this will do the inverse of whatever it's currently set at by setting the enabled property equal to itself with a not in front of it. So if it's enabled when the tick event is fired, then it's going to disable it. If it's disabled when the tick event is fired, it's going to enable it. So it's just doing the reverse. So let's test this out. I'm just going to go ahead and run the application. I should run it. There it is. So by default here, we're set up as green. The animation is running. We're going. Let's slow it down. Let's hit slow, and now it looks like we're slowing down before we come to a complete stop. And check it out. So that's our switch statement doing some work there. Now it's slowing down again, speeding up. We can go from go to stop, stop to go to yellow, and it'll run all that code as it should. So there's a simple switch. Let's take a look at a more complex version of the switch statement so you can see the power of what you can accomplish with the switch statement here. So let's just close out of this WinForm project. We'll collapse it. Let's set up our console application as our startup project. Go into the code behind here. I'm just going to collapse our previous if statements that we were working with. I'm going to paste in here some code. And this code is called complex switch. Let's also change the call on our entry point to complex switch. And let's take a look at what this code does. Same kind of deal here. We're going to get some information from the user. So we're going to ask them what size ice cream cone would they like. 1 for a small, 2 for a medium, 3 for a large, and 4 for a stomach ache. And then we're going to store that value inside of a variable called scoops. And then we need another variable here because we're going to calculate the cost based on what they enter into the console window. And then we've got our cost structure set up so we can reuse code. All right, so here's what we do. We're going to do a switch on the scoops to find out how many scoops they entered. If it's 1, it's going to act like our simple switch statement where we're just going to set the cost equal to 25 cents and break out of the switch statement. Now this cost plus equals, what this does is this adds to the variable. Or if we were to just do an equals 0.25, it would overwrite the variable. So we're just increasing the variable by this amount using a plus equal sign. And that really comes into play if they were to order something like a medium, which is a 2. So a 2 would come in, we would increase the cost by 0.25, and then instead of breaking, we would go to case 1, where it would then increase the cost by another 0.25. So you can kind of see our cost structure here. We're just increasing it by 25 cents each size, except for the stomach ache, number 4, we're going to increase it by 50 cents. So it's a great way to reuse code here, and it's a much cleaner way as well of writing this, because you can see here, we're just using go-tos to go to the case. So if we order a 4, it's going to go to case 3, add 25 cents, go to case 2, add 25 cents, go to case 1, add 25 cents, and break, in which case it would get out of the switch statement. The default is if none of these conditions are met. So if scoops is anything other than 1 through 4, we're going to run the default and say, hey, sorry, we don't carry that size, and then break. And then at the very end here, we're just analyzing the cost to make sure if it's greater than 0, we're going to say that'll be, and then the cost, please, thank you, and enjoy. So in the case that they do enter 1 through 4, the cost will be greater than 0, and that code will run. So let's test this out. And I'm just going to hit Control F5 first. And let's just type in a small. What do we get? Oh, it costs a quarter. All right, thank you and enjoy. And if we hit Escape here, and I'm just going to hit Control F5 again. And this time let's type in a medium. Let's do a large. That should be 75 cents. Thank you and enjoy. And the last one here, let's type in, how about 100? We don't carry that size, sorry, but you can see it didn't give us the cost there because of our if down there. Now, let me show you something, and we're going to cover debugging in a future nugget, but this is good to see now because it's great to watch your code execute. You can really get a good understanding of how your switch statements and your if statements are performing. Let's just set a breakpoint, which is right here. You click in this gray area over here. That'll set us a little red dot, which tells us when we run the application in debug mode by hitting F5 or clicking on the play button here, not Control F5 because that just runs the application. But if we run it in debug mode, it's going to stop at this line of code where we can start analyzing it and we can walk through the code line by line. So let's hit the run button and let's type in a stomach ache here, 4, hit enter. You can see code is going to break right here. That's why they call it a breakpoint. And now if you hold your mouse over here, you can see tooltips. We can see what the value of scoops is and all of our local variables that we have declared. Cost is currently 0.0. And now we can step through this code. We can start executing it line by line. So if we hit next, it's going to go to 4. So far everything's working great because that's what we typed into the window, 4, so it goes right into our case statement. Now the next line of code is going to add to cost 50 cents. And there it is. So now we're at 0.5. If we hit it again, we're going to go to case 3. It's going to increase it by another 0.25, which it does, as you can see down here in the red. Now it's going to go to case 2, increase it another 25, go to case 1, another 25, and that's going to be the final cost there, 125. Now we're going to break, which takes us out of our switch statement and into our if statement. There's our cost, which is greater than 0. So now we're going to break into our if statement here, run that, output it to the console window, and that's that. So there's a complex switch statement, so you can see the power of switch and how you can use it when you have many conditions, and also how you can jump around in your conditions, and also, if no conditions match, how you can run a default. So this is kind of like our else here with if statements. Alright, so in this CBT Nugget, we took a look at decision structures. We started off with an introduction to decision making within our applications, got an understanding of what algorithms are, just a way to express and solve a problem. We saw that we can express them on paper using flowcharts and decision tables, and how these are great tools that you can use to map out not only program flow, but cases where you have many conditions within your application that you need to map out ahead of time. It's great to do that on paper, then it makes it easier to translate them into the main constructs for making decisions within C#. And we saw that would be the if statement and the switch statement. Then we got a good demo of each of them. We took a look at a simple if statement, kind of evolved that into an if-else, and also a nested if statement using multiple conditions. And then we took a look at the switch statement, took a look at a very basic switch statement, and then a complex switch statement. I hope this has been informative for you, and I thank you for viewing.